Hello. I am Alexei Fedorov, and this is the third episode of TDD Screencast. In the last episode, we have implemented a sorting algorithm using TDD without thinking about algorithm beforehand. As a result, bubble sort have emerged. We have noticed that there is a small weird thing about this implementation. It had unspecified behavior, mutation of the original array. So we ask ourselves, which algorithm would possibly emerge if we were to ban such sort of side effects from our algorithm? So let's find out. I already have watch.sh running, so I'll probably just open my Vim and jump into the coding. So I will probably call this sort I don't know. I'll call it cool sort. Oh, nice sort, because it is nice to the user. No, I'll call it kind sort, because it's kind to the user. So it's spec kind sort spec.cr require spec helper as always. Did it work? Yeah, it did. Okay, cool. So let's do the same things. Kind sort will fail. Let's define this module as we did last time. Yeah, and require it. Okay, now it passes, or kind of. It sorts. Let's start from empty arrays always. Oh, I like doing this now. I think it just reads better. Kind sort empty. Which will fail because we don't have such method. Undefined method sort, as you can see in my notification bar. Yeah, I modified my watch.sh script a bit. So now it actually grabs compiler errors and shows them to me, which is pretty nice. So let's define it and do nothing inside. It is successful. By the way, you can grab my watch.sh script and play around with it. Now it supports both Linux with iNotify tools and Notify Send, and macOS X using two libraries that you can install with Brew. Script itself has comments how to install those libraries. It's just two commands. So let's move on. Now we have the right to actually make some expectations. So when we sort empty array, it should equal to empty array. We have our expected failure, and now we need to return empty array. I'll do the same thing here. I will define empty at the method that returns empty array. Since I might want to internally in this function at some point mutate something, maybe erase, just not the original one, I want it to be a function that returns new empty array each time when you call it, so that we don't have problems and unexpected bugs. Okay, that should work. Cool. Let's sort one number. fails as expected. Now we need to just generalize from empty array to variable. It works. So good so far. Now let's actually sort 1 and 2, which should return 1 and 2, and it will still work. And now let's reverse order in the array, which will fail. Now the interesting thing happens. If we are just going by TD, nothing stops us from actually breaking the rule that we were supposed not to break. But bear with me and see what happens next. So I will do the same thing. I will ask if first two elements are not in right order, and I will swap them if they are. And of course we need to check for size here. Okay, it succeeds. And now what I do, I actually add something to my specification to verify that original argument is not modified. It does not modify original array, which will put in a variable, it will be 2, 1. We'll make a sort of the thing. We'll as well make an expectation that the order is correct. And then we check that variable a, our argument, wasn't modified, which will be 1, 2. What? Ah, actually 2, 1, sorry. That should fail. and it fails. So now we simply have to do something about it. What we can do? Well, we can copy array and just operate on second array, but I don't want to do that because we know that we will end up with bubble sort. That's not the goal. And the goal is to maybe make a return of a new array with elements that are ordered differently, which is pretty simple. It will be array that contains a1 and a0. That should pass. Yes, that passes our test, which is very nice. So let's continue on writing more tests for that. Let's move on to 3-element arrays. Correct ordered array should just work. Cool. Now if I change order of first and second, I expect it to fail because we are doing here a strange thing. Basically just ignoring third element. So to fix it, we want to actually just put it there at the end, which will be a from second element and to the end of the array. So basically from second element and onwards. And succeeds. So now, what about feeding it something like that? 1, 3, 2. So that should fail because we are not doing anything with third element at any point of time. Let's see. So how would we fix that? So we have our code here. What is the minimal thing that we can possibly do to make it pass? So let's imagine that after this if is verified, A0 and A1 were in correct order. So we end up here returning A. So what happens if we return A0? Because we know that it is at least less than A1. It is not the minimum in the array, but at least it is less than A1. And now we append sort from A1 dot dot minus 1, which will basically cut off first element, just put it there, and we'll sort the rest of the array on the right and concatenate it to our A0, which should work for this spec. I did something wrong there, and I know what I did wrong. Basically now I'm actually trying to access A0, and it will not work for first test case where we operate on empty arrays. So what I would say is return A if added size less than 1 equals 0, but less than 1 works too. Okay, I think it just succeeded, right? Yeah. So we can continue on and writing some more tests. Let's try 2, 3, 1. That probably won't gonna work. It doesn't work. So what happens there is that it sees that 2 and 3 are in correct order within themselves and moves on to this line. Say that 2 is at its own place and shouldn't be touched, and then sorts right part of the array, which will swap 3 and 1. Yeah, which is not really correct. So how do we fix that? So before fixing that, what can we do about our return statement? I don't like this return statement. I think that's very specific. So we have very specific case where we return from a function. I'm not talking about guard statement. Guard statements are okay, but this thing is very specific. And this thing kind of looks generic. So maybe we can eliminate this return and just do something that will allow us to return correct array by this line. For that, I will comment out my failing test, return to the green state when everything passed, and I will try to refactor it a bit. So what is in common between this and this line that could possibly be used to generalize? So we have some sort of elements on the left, then we have A0, and have some sort of elements on the right. So it would be correct to write this like in this way: plus A0 plus A2 minus 1. And here we will have empty plus the thing. That should still work. Yes. So now this empty and A1 is a difference, and sort A1 minus 1 and A2 minus 1 is a difference. I can tell you for sure that it is safe to do this, because we concatenate arrays, and if we concatenate already sorted array, we will obviously be fine to go. So that makes it a bit better. So let me think on the left of A0 left, and think on the right of A0 right. So we'll say left equals empty by default, and right equals a1 minus 1 by default. And then in this if statement, then I'll simply assign left to a1, and I assign right to a2 minus 1. And I will not have return statement here. And here I will use left and right. So that's kind of complicated refactoring, because I brought the code to make the code similar, and then extracted variables out of there. Yeah, and then eliminate my return statement by reusing this line that it will actually return what I want. Sorry. Okay, let's save it and see. Okay, it still works. So now I will actually uncomment this back. It will still fail because we didn't quite change the functionality, except for adding the sort, but I think it's harmless. Now, what should we do to make this thing pass? So our A0 is 2. It will be somewhere in the center, and we want to somehow have 1 before. How can we do that? Let's try copying this if, and then saying that if added size more than 2, so we have more elements, and A0 is more than A2, we want to put A2 on the left. And then we want to have A1 on the right. Is that correct? I think it is. So let's try that. It passes. Interesting. So the code in 2ifs is similar, but not exactly. What can we do to actually make it similar? Well, we can say here, instead of a2 minus 1, we can say a2. No, we can't. Yeah, we can't. So that's actually how it works. Okay, I will not refactor this right now. I will rather try to break it by using 3, 2, 1 test case. Okay, so what's doing now? 3 and 2 in the wrong order, so it will assign array A1 to left, basically assigning 2 to left, and then it will assign 1 to right. Then the next if comes into play, and to verify that first element, which is 3, is in order with 2, and we will assign this last element to the left and second element to the right. So what we end up is left is 1 and right is 2, and we have 3 in the middle, which I think is exactly what we get here, right? 1, 3 and 2, yes. So that's quite interesting. So I have a feeling that assigning this thing to the right is not a good idea. What we could have done is something like this. A1 So this is the same thing, right? Yeah. NA2 here. This should be the same thing too. Oh, not really. Not really. So we get more things on the left. Yeah, so right should actually be empty. And we can't assign it like this. So it seems like what we want to do is something like this. It seems like this to me. That won't work because we need to extract this if. And here too. Okay, let's see. Something actually doesn't work. Oh, segmentation fault. We did something really wrong here. Segmentation fault probably means stack overflow. Which means, so if A0 is the wrong order with A1, then, yeah, right is incorrect, so it should be empty now. Okay. So now we have a failure, but that's very interesting failure. So we have 2, 1, and 3. So our first element got to the right place, and only thing on the left were inserted. Well, that's because we don't sort thing on the left, but sorted. Okay. So now I want to refactor those two ifs, which are obviously duplicated by extracting the variable and then generalizing. So I equals 1, I, that should still work. And now if I copy this and replace this if with this if, and we'll just change I to 2, that should still work. Okay. So that is a loop, obviously, which can be just that's actually this if turns into while instead with the same condition, and we put I plus equals 1 on the end and remove duplication. Okay, this still works. We have a bunch of ways to improve on it. We can just say from 1 to -1 each do x, and we replace this e with x, and we don't need index increment anymore. Okay, this works. So now let's just try to. So I'm sorry, that's where sound got problems. It just sped up and was much faster than video. So I had to record sound for this part separately and then just apply the sound here to the video. So yeah, I'm passing and sorting this array manually, usually using my eyes. Yeah, using commas, using dot command on Vim. Tedious operation. You probably can just fast forward a couple of seconds here. There's nothing to say about sorting numbers manually. Yeah, 95. Oh, 95, yeah. Okay, let's see if it works. Oh, it actually worked. That's cool. So now I think that algorithm is done, and it's actually a quick sort, as you can see. I think I'm going to refactor it here for you because I don't like big methods. And yeah, commenting down this return is not gonna work, so we need it. I feel like I'm pair programming with myself now. Oh my god, what am I doing? That's actually a pretty interesting concept, I think. To record you programming and then commenting after that. Oh, that's interesting. Maybe I can try to make the whole episode like this and see how it works. Yeah, so basically extract partitioning part that spits out two arrays in a tuple. Then we'll just assign them here to variables. You add tuple destructuring and it should still work. And it works. That's pretty cool. Now this ugly if else statement. So I can barely relate if statements if they're not guard statements. If else statement is a no-go for me. So let's extract this logic so that it will be much shorter and simpler. Yeah, that's basically a method that would determine to which part you need to add this x given the y, and y is a0 usually, or something else. And give it left and right, and it will return you either left or right. Yeah, that was a typo there. Okay, and now let's use this function using part 4 a0 x left right and then append x. Okay, that should still work. It does. That's pretty cool. So yeah, I think the refactoring is done. That was pretty nice quick sort. It is not the most memory efficient implementation, but it is something that is actually pretty simple to optimize. Instead of passing recursively arrays, you pass original array and two indexes, pair of indexes. It is a classical implementation, which means that we choosing 0 first element for partitioning. We could choose random element here, but that's yet another optimization. And the interesting thing that even though it is memory hungry, but it eats memory only as much as comparison operation it does. So it is on average n log n, in worst case n quadrat as time is. When optimizing it through indexes, we'll have to copy array once and then mutate this copied array so that we don't violate our it does not modify original array specification. I'm not gonna apply this optimization here, or at least not in this episode, and I will just leave it as an exercise for you, my users. And the next episode, yeah, here I was probably showing this. Very sorry about sound. So in the next episode, I want to look into pathfinding problem, and I want to actually understand if those techniques are applicable there. I hope they are, and I will actually do some research before making an episode, and we'll see how it works. So see you next time. Have a nice day.